Hello everybody, welcome back. While reviewing part 7, I realized that I had left out some details on the transformer selection and some of the installation. So this is part of the lost episodes that I found in the archives. Part 7 was already too long, so I wasn't going to add it, go back and add that. So I just thought I would have a little update here. So sit back and relax, and hopefully this will give you a little bit more information. As we left last time, we had determined that the secondary of this Interstage Transformer was open. I cut it open, and sure enough, the leads were corroded on all 3 terminals. I was thinking about maybe I could salvage it, but I didn't want to try it, because we're talking about an 86-year-old transformer. Okay, it would have been nice, but I don't want to have to tear this apart again. I located one on an acquaintance on eBay, and before I could buy it, someone else snatched it up. But then, thinking on second thought, that was an 86-year-old transformer also, so decided to go with a modern replacement. This transformer is a 1 to 2.1 ratio. Okay, the modern replacements are about 1 to 3, which is adequate. It's fine. And of course, you see the DC resistance. The modern transformers will not have the same resistance, and this is, I believe, is the quality of the transformers. Today we have better transformers, better cores, better winding, etc. So the DC resistance will be less than these. Okay, but the impedance is and the matching is what we're looking for. This transformer does 2 things. Number one, it matches the impedance from the plate of the 27 tube to the grid of the 45 push-pull amplifier. And that's not the DC resistance, that's the impedance, the matching. Okay, it also, as you look, this takes the B plus, goes through the transformer and feeds the plate of the 27 tube. That's the DC component. Now the AC component, which is the audio coming off the 27 tube, will be induced into the secondary windings of this transformer. That provides a little bit of voltage boost on that audio, which feeds this amplifier. So it's more of a signal when it gets to these tubes because of this transformer. Now, we could match the impedance from this tube to these tubes with resistors, capacitor circuits. Okay, and you'll see that in other radios as you work on more of them. But you don't have any gain. You have no voltage gain. So you would have to add a tube to boost that voltage to go to these tubes to get adequate gain. And since this is a push-pull, you'd probably have to have, and the amplifier tubes could be the same thing, you'd have to have an inverter tube to reverse the polarity or the phasing of the output where this transformer does it. You'd have to have the tubes to do the inversion here. So in 1931, the transformer was the best selection because, number one, it was during the Depression, and adding a tube to the circuit would have been more expensive. Now later on, you'll find manufacturers add tubes and boast about adding the tubes. It's more of a tube. It's a better radio. Well, not necessarily in every case is it a better radio, but they would sell the tubes, the number of tubes. Okay, that was a selling point later on. But in this case, it was a depression. They didn't want to add cost, and this was it's one of the first mantle super heterodyne receivers that came out on the market. So that was one of the reasons for this. All right, getting back to my selection and why I selected, I went and talked to a guy that had redone an R7 before, and his advice was do not use a Stancore A53C equivalent, and that's exactly the transformer that I, in my mind, was looking at. And he said it did not have enough iron in the core, and that it would have distortion in the audio. Well, after talking to him extensively, I found out that he had, when he restored his 7, he never tried the A53C equivalent. He never tried it in the radio. So it was based upon, I guess, other experiences with that transformer or what have you. So I went to someone that I have trusted and gotten a lot of information and a lot of advice from in the past for the Atwater Kent and some of the other 30 radios that I've worked on, is Norm Leal, and out in California, and he has done many radios, and he is what I consider a subject matter expert. And guess what he recommends? He recommends the A53C equivalent. So he also went on to, I had thrown the transformer out there on the table, what I was looking to use, and he said, well, you can use that and it's fine. But he recommended the Antique Electronic Supply generic. It's a 1-to-3 ratio, and it cost a whole, the one I'd picked was $46, and the one that he picked was $17, I believe. So anyway, he saved me a little bit of money there. So anyway, it's a whole lot better. And what he told me about the audio quality, I told him what the other guy had told me, and he said, listen, the audio quality was limited to the design of the radio. This is one of the first super heterodynes that came out, and the audio quality is limited to the design. It's not necessarily this particular transformer. And if you remember looking at the speaker, so even when it was new, in good condition, the speaker just would not have been a good performer. All right, I've already started with the transformers. The generic one that I got from Antique Electronic Supply is the P-T156, and that's equivalent to the A-53C 1-to-3 ratio. And I've already started. Now what I've done is I've bolted these together with a screw. That's all I've done. Now I put a spacer in between simply, and I can't tell you why I done it other than the fact that I didn't want this clanging together, and that's it. I went ahead and cleaned up and painted the box itself, and we'll use the cardboard liner again. Also did the capacitor, RF bypass capacitor can also. So I've started doing some wiring on this, and I'll show you what I've done to this point. I'm using smaller wire except for the speaker and the speaker wire. I'm using the cloth just to make it look like the other ones, and it'll be on top, and then you'll be looking at it. So that's the only reason. And I'm using the small hookup wires under the bottom simply out of space. It's the same gauge of wire, but because of this reproductive cloth on here, the lacquered cloth, it's just a lot larger. And with 9 wires coming out of that can, it's going to get crowded. So that's what I did. All right, I drew up the schematic for this, and you can see what I'm doing. The transformer primary had a blue and a red wire, so I connected the blue wire to the green, which will go to the B plus, which is on terminal 14 of the resistor board. And then I've going to connect a yellow wire to the red, and that goes to terminal 12 of that resistor board, which is yellow, which that goes to the plate of the 27. Now the secondary has a green wire and a center tap black for the secondary. And if you'll recall, the blue wires came out and went to the grids, pin 3 of the 45 tubes when we were troubleshooting it. So the green wires, I just converted them to blue wires. And then the center one was black, and it also goes to terminal 9, which is exactly in between the 100K resistors. And it was a black-blue wire. So what I did is I took a blue wire and I put black marks on it. So that's that side of it. Now the output transformer is the generic one also, which you can get several impedances out of it. And I've put the heat shrink over the terminals that I'm not using. And the looking at the website radioremembered.org, it has an output transformer impedance chart, and it has a lot of the tubes that'll be used and their impedances on the plate, and the plates of the 45 show about 5,000 ohms. And the schematic for the transformer shows that at 4 ohms, and I went back and looked at my video. I did not get a good reading on that voice coil, and I had a subscriber make a comment on it, and so I went back and I checked it, and I did get a good reading when I went back after I got it out and laid it on the bench. I got 3.5 ohms, which that's DC resistance. And using the rule of thumb of 1.15 or 15% above that, multiply that, and it gives you pretty much roughly ballpark of what the impedance of the voice coil is, and it comes out about 4 ohms. Using the chart with the transformer, the PT291, using the 4 ohm speaker, if you use the common and the number 2 for 4 ohms, then that will give you an input of 4,000 ohms. As I've been splicing these wires, I've been putting heat shrink on those, and I also put heat shrink on the terminals that I'm not using on the transformer. But I'm going to go ahead and do the terminations of the rest of the wires, and once I do that, I will take and I will insert it in our can thusly. And so now it sits down in like that. I will take and I will put the wires down in there, and then to keep it from rattling around, I'm going to use some of this stuff. It's crack filler, insulating foam. It expands. I'm only going to use a small amount just to keep it from rattling, and that's pretty much it. And then when I get done, I should have all the wires with the proper color codes coming out and ready for the can to go back in. Now, before I do the foam, I'm going to terminate all the wires. And then I'm going to take my ohm meter and I'm going to check them to make sure that they are consistent with what. Make sure I didn't make a boo-boo, which, believe it or not, I do make boo-boos on occasion. But that's just a good thing before you, it's basically a dry fit. You make sure everything's right before you put it to where you don't have to tear it up to get it back apart. But, all right, let me terminate these wires and finish this foam stuff, and I'll show you the results. I've sprayed the great stuff, the insulation foam, down in the can, and I pressed the to make it flat so I won't have to do any trimming. And I did check the continuity and document it on my sheet to make sure that I did get the leads in the right place. I put some heat shrink on this so it'll come up through the chassis. I don't know that I'll have room for a rubber grommet, but that'll add extra protection there also. And we'll let this cure for a few hours, and then we'll start putting it together. Well, I apologize for the lost footage. It's a little over 16 minutes, and I think it was good information I needed to share. It's not hardly 18 minutes, but I think President Nixon would have been proud of the lost 16 minutes. But picked up a few new subscribers, and I really appreciate those. I appreciate my viewers, and I appreciate all my comments. So, from Larry from the hills of Tennessee, thanks for watching.